We'll now discuss an introduction to equations and what exactly they are and how we solve them. An equation is just a statement in which two different expressions are set to be equal to each other. We're going to focus on equations in a single variable, which means there's only one variable in the equation. It may be represented multiple times, however, there's only a single variable. And then we just set the two sides equal, and that's what makes an equation. Equations can be either true or false. For instance, if we have the equation x plus 5 equal to 9, and I say let x be equal to 1, then this would be a false equation. However, I could also say let x be equal to 4, and then it's a true equation, but either way it is still an equation. We'll now look at solutions to equations. So this is really what we want, and the whole point of solving an equation is to find its solution. A solution is just different values of the variable that results in a true statement. So it's what we can do whenever it's true. For example, when we had x plus 5 equal to 9, our solution would be x equal to 4, because we know that 4 plus 5 is equal to 9. We can also have more than one solution. For instance, if we have something like x squared minus 1 over x plus 5 equal to 0, this actually has two solutions. So we can have multiple solutions. In particular, these solutions are 1 and negative 1. And you can double check that by sticking them in and seeing that it results in a true statement. And this is called a solution set. When we have more than one, the solution set is all possible solutions. We typically write it between curly braces and typically in increasing order. Next, we'll look at an identity. An identity is a particular type of equation. This is an equation that is always true. It doesn't matter what you put in for x, you'll get a true statement. For example, if I have the equation 4x minus 6 is equal to 2x plus 1 plus x minus 9 plus x plus 2. This is an actual identity. And the main reason why is if I look at this right-hand side here, I can see I have a 2x, an x, and an x. That would give me 4x. I also have this 1, negative 9, and plus 2, which would give me a negative 6. So both sides of the equation represent the same thing. It doesn't matter what value that you pick for the variable, it will result in a true statement. So this is an identity. The next thing we need before we start solving equations is this term equivalent equations. These are equations that have the same solution set. So it's things where the actual solutions don't change. And these are important because in solving a system of a set of equations, our goal is to take an equation and turn it into an equivalent equation that's simpler to solve. For example, if we have this equation 2x plus 5 is equal to 11, well, this is equivalent to 2x is equal to 6. And this is equivalent to x is equal to 3. And we'll walk through a little bit later how we got to each of these steps. However, you can see that they all have a solution set of 3. And you can double check that by sticking 3 into each equation and seeing that it results in a true statement. We'll now look at different things we can do to an equation to turn it into an equivalent equation. And in particular, there's going to be 5 of these. The first is to interchange two sides, and this is a very basic one. It's basically saying that x equal to 3 has the same solution set as 3 equal to x. It doesn't matter if the x is on the left or the right. As long as it's the same numbers, we'll have the same solution set. The next would be simplifying sides of the equation. This involves getting rid of parentheses or combining like terms. For instance, if I had 2x plus 3 minus 4 equal to 1, I could get rid of parentheses to have 2x plus 6 minus 4 equal to 1, and I can combine like terms. 6 minus 4 is 2. So these are all equivalent, and all I did was simplify one side of the equation. The next one will be to add or subtract the same thing on both sides. For instance, 2x plus 4 equal to 7. If I subtract 4 from both sides, I'll be left with 2x is equal to 3. So these are equivalent, and all I did was subtract 4 from both sides. So this is the third allowable operation. The next thing is we can either multiply or divide both sides by the same non-zero expression. It's important that we note that it has to be non-zero. So for instance, this equation that I just had, I can divide both sides by 2. 2 divided by 2 is 1, and then on the right, we would have 3 divided by 2. So we can either multiply or divide both sides. The last thing we'll look at is called the zero product property. What this says is that if we multiply two things and the answer is 0, then we have to have one of two situations. Either A is 0 or B is 0. Basically, if you multiply two numbers and you get 0 as the answer, one of your original numbers had to be 0. We'll now walk through solving a basic equation. So the idea, the first step, is to have all of your variables on one side of the equation and your constants on the other. Here, our variable is on the left, so we're going to get our constants on the right. And I'm going to do that by subtracting 7 from both sides. So here is 0. So on the left I have a 3x, and on the right I have negative 5 minus 7 is negative 12. Next, I want to get rid of this number in front of my variable. So I'm going to divide both sides by 3. 3 divided by 3 is 1, and negative 12 divided by 3 is negative 4. So now I have the solution.